So this will be our example number 3. So as I have said, the number of nodes, okay, will be equal to the number of the equation. Okay, so from here we would first, of course, determine our reference node, in which it was already identified in the circuit, which is this node, or it was identified our node 0. Okay, so after determining our reference node, now let us determine our non-reference node, which is identified as our node 1, our node 2, and our node 3. As a tip, so before solving any current or voltage in the circuit, try to analyze what are the sources that are present in the circuit. So we have two kind of sources, which is an independent current source and a dependent current controlled current source. And the current Ix is controlled by the current entering in our 2 ohm, which is also identified as Ix. Now, after determining or clearly discerning our analysis in this equation, so let's solve for the problem. So of course, what we do is to have our current direction. So I have my I13 meaning from V1 to V3, and this will be my I12 meaning from V1 to V2, and of course I23 from V2 to V3. And of course, you have another current. I have my I20 from V2 to 0 potential. Now, the current 012 or I012 was already given as 3 ampere, and the current I30 is already given as 2Ix. So the next thing we do now is to take our KCL at node 1. So I would take my KCL at node 1. Therefore, what are the currents entering and going out my node equal to 0? So I have my I13 going out my node, so therefore this is negative I13. So negative I13, positive 3 ampere, and negative I12. Take note that our I12 is of course equal to my Ix. But what is my I12? Notably, our I12 is equal to V1 minus V2 all over 2 ohms. Same is true with my I13, which is equal to V1 minus V3 all over 4 ohms. And my I23 is equal to V2 minus V3 all over 8 ohms. Okay? So from that, we would substitute different values into our equation. So I have my I13, which is equal to negative multiplied by V1 minus V3 all over 4 plus 3 minus my I12. So minus I12, which is equal to V1 minus V2 all over 2. So from here I will have negative V1 all over 4 plus V3 all over 4 plus 3 minus V1 all over 2 plus V2 all over 2 equals 0. Now, before this, or before we would finally compute this one, so it is better to combine our like terms, okay? Because simplifying our equation y when it is earlier is better, okay? So from here I will have my V14, which is my V1 negative V1 over 4 minus V1 over 2 plus V2 over 2 less V3. This would become positive. So V3 all over 4 equals 0. So take note of our signs. Why? Because basically it may make or break our careers. Okay? So from that, I have negative 1/4 minus 1/2 is of course negative 3/4, or negative 3/4 V1 plus V2 over 2 plus V3 over 4, and our 3 ampere, which can be written as equal to negative 3 ampere. Okay, so this can be our equation 1. Next, so we have 3 nodes, non-reference node, so therefore we will make 3 equations. So let's have KCL at node 2. So if I would take KCL at my node 2, the tendency is that I have IX, or my I12 going into the node, I12 going into the node, and I23 going out the node, and I20 is going out the node, equals 0. So my I13, or my I12 I should say, is B1 minus B2. So B1 minus B2, B1 minus B2 all over 2. My I23 is negative V2 minus V3, so V2 minus V3 all over 8. And my I20, so I20 can be written as B2 all over 4 minus